Okay, so what if I told you that the ground, the very continents we live on, aren't fixed in place at all? What if they're actually moving all the time? Now I know today that's basic geology, but not too long ago, that idea was considered completely ridiculous, one of the craziest theories in the history of science. This is the incredible story of that idea.
You've probably done this, right? You're just staring at a world map and you can't help but notice it. The way the bulge of South America seems to just slot perfectly into the curve of Africa. It feels like a clue, doesn't it? Like the Earth is this giant, shattered jigsaw puzzle? Well, that one simple observation would end up triggering a scientific earthquake, completely upending our idea of a static, unchanging planet.
And the man who dared to actually put this puzzle together was Alfred Wegener. Now get this, in 1915, this German meteorologist, not a geologist mind you, proposed the theory of continental drift. He had this vision of a time when every continent we know was jammed together into one giant supercontinent, which he called Pangaea. And he believed that over millions of years, it broke apart and drifted. This was a wild claim, and he knew that to prove it, he was going to need a mountain of evidence. And that is exactly what he set out to build. See, Wegener wasn't just some armchair theorist. He was a serious scientist and an explorer. He went all over the world, gathering clues from totally different fields of science, all to build his case. He was literally assembling a mountain of evidence, one fascinating piece at a time. He ended up organizing all his proof into four main categories. You can think of them as four chapters in this epic geological detective story. First, the obvious jigsaw fit. Then, the clues he found hidden in matching rocks. After that, the testimony from some very old fossil friends. And finally, the really strange case of ancient climates showing up in all the wrong places.
So first up, the most obvious clue, the one that started it all. It wasn't just that the coastlines kind of looked like they fit. Wegener took it a step further. He showed that if you look at the continental shelves, which are the true edges of the continents just underwater, the fit between South America and Africa is, well, it's almost perfect. It was just way too precise to be a coincidence.
But he didn't just stop at the shapes. Wegener started looking at the rocks themselves, specifically at mountain ranges. And he found that the Appalachian Mountains over in North America are, for all intents and purposes, geologically identical to the Caledonian Mountains in Scotland and Scandinavia. We're talking same age, same rock types, same structure. It was like a single massive mountain range had just been ripped in two by an ocean.
And then came the fossils. This part is just mind-blowing. Paleontologists kept finding identical fossils of land animals on continents separated by thousands of miles of ocean. You take a land reptile like Cygnothathus. There's just no way it could have swum across the entire Atlantic Ocean. It couldn't happen. The only logical explanation was that these continents were once connected and these animals just walked across. Wegener's final piece of evidence was basically frozen in time. Geologists were finding these deep, unmistakable scars in the bedrock of places like South Africa and India, scars left behind by enormous grinding glaciers. But hold on, these are tropical places today. How could they possibly have been covered in ice sheets? Wegener's answer was simple. They weren't always tropical. At one point, they were all huddled together much closer to the South Pole.
So, let's recap. Wegener presents this unbelievable, airtight case, right? The shapes fit, the rocks match, the fossils line up, and the ancient climate data makes perfect sense. The evidence was just overwhelming. And yet, the scientific community of his day completely rejected it, flat out.
And this really is the central mystery of the whole story. With so many different lines of evidence, all pointing to the exact same conclusion, why was there so much pushback? What on earth did the scientific establishment see? Or maybe, what did they refuse to see? And listen, this wasn't just some polite disagreement. It was hostile. This quote here really captures the mood. The establishment didn't see Wegener's idea as a brilliant new insight. They saw it as an attack on everything they'd built their careers on. To them, it was just utter damned rot. The rejection really boiled down to a few key things. First, Wegener was an outsider. He was a weather guy telling the rock guys how their field worked. Not a great look. There was also a bias. A lot of his best evidence came from the Southern Hemisphere, which many of the top scientists in Europe and North America had never even been to. But the real nail in the coffin, the fatal flaw, was one single devastating question that he just couldn't answer. How? What force in the universe could possibly be strong enough to push entire continents around the globe?
Tragically, Wegener died on an expedition in Greenland in 1930, with his theories still pretty much laughed at by the scientific community. For decades, it really seemed like his ideas were going to be nothing more than a weird footnote in history. But, sometimes a brilliant idea just needs to wait for technology to catch up.
So the story went cold for almost 30 years. Then, in the 1950s, new sonar technology, stuff developed during World War II, gave us our first real look at the bottom of the ocean. And what we found down there changed everything. We discovered these massive underwater mountain ranges crisscrossing the entire planet. And we found proof that the seafloor itself was spreading, that new crust was literally being born at these ridges.
This incredible discovery led directly to the theory of plate tectonics. And it turns out, Wegener's missing mechanism, that giant force he couldn't explain, had been hiding under the oceans the whole time. The Earth's crust isn't one solid shell. It's broken up into these enormous plates that are floating on the hot molten mantle below. And the engine driving it all? Massive convection currents in that mantle, acting like a giant planetary-sized conveyor belt, pushing and pulling the continents all over the globe.
So, if you take one thing away, let it be this. Wegener was absolutely right about the what. The continents are moving. He was just missing the how. Plate tectonics provided that missing piece of the puzzle, and in doing so, it didn't just prove Wegener right, it created a whole new framework for understanding pretty much everything about our planet, from earthquakes and volcanoes to the very mountains we see on the horizon.
Wegener's story is just such a powerful reminder that science is a process. It's always evolving. And sometimes the biggest, most important breakthroughs come from outsiders who just dare to look at the world a little bit differently. It really makes you wonder, doesn't it? What accepted truth that we all believe today is just waiting for its own missing piece to be discovered?